Topic is classification of magnetic materials. How many types of magnetic materials? Magnetic materials are five types: diamagnetic material, paramagnetic material, ferromagnetic material, antiferromagnetic material, ferrimagnetic material. So we have five types of magnetic materials: diamagnetic material, paramagnetic material, ferromagnetic material, antiferromagnetic material, and ferrimagnetic materials. First we discuss diamagnetic material. An electron moving around nucleus results magnetic movement. Due to different orientations of various orbits of an atom, the net magnetic moment is zero. An electron moving around nucleus results magnetic moment. Origin of the magnetic orbital magnetic moment. Due to different orientations of various orbits of an atom, the net magnetic moment is zero. When magnetic field is applied, all the magnetic moments of its atom will align in the opposite direction of the applied field. We give the magnetic field, all magnetic moments of its atoms will align in the opposite direction of the magnetic field. The relative permeability mu r less than 1. Susceptibility chi is negative. Chi is independent of temperature. Example for diamagnetic materials are or- organic materials. Examples for diamagnetic materials are organic materials. Second one, see here the alignment of magnetic moments in the opposite direction of the applied field. Second one, paramagnetic material. Each electron in an orbit has an orbit and a orbit magnetic moment and spin magnetic moment. Each electron in an orbit produces orbital magnetic moment and a spin magnetic moment. When shells are unfilled, there is no magnetic moment. In the absence of external magnetic field, the net magnetic moments of atoms are arranged in random directions because of the thermal fluctuations. Hence, there is no magnetization. When external field is applied, all the magnetic moments align into the direction of the magnetic field. The induced magnetism is the source of the paramagnetism. Relative permeability mu r less greater than 1. Susceptibility chi is low and positive. Chi is equal to C by T where C is the Curie constant. Example alkali metals and transition metals. See here without a field they are aligned randomly due to the thermal fluctuations. When you give the field, they are arranged regularly along the direction of the field. That's why they show the magnetism. Here we give the graph between temperature and susceptibility, and here 1 by T and susceptibility. Ferromagnetism. In ferromagnetic substances, the permanent magnetic moment is mainly due to the spin magnetic moment, which will be aligned parallel to each other. Spin magnetic moment which will be aligned parallel to each other. In the absence of external field, they exhibit magnetism. This is due to the spontaneous magnetization. There is a special form of interaction called exchange coupling occurring between adjacent atoms coupling their magnetic movements. In magnetic materials, in the absence of magnetic field also, they exhibit the magnetization, they show the magnetization. This magnetization is called the spontaneous magnetization. This is due to the exchange coupling occurring between adjacent atoms in the magnetic moments. Relative permeability mu are much greater than 1. Susceptibility chi is high and positive. A transition and parallel earth metals. Chi is equal to C by T minus TC. TC is the Curie temperature. See here, non-magnetic material, and here domains. These are called the domains. In ferromagnetic materials, some small portion is we call domains. In the domains, all are aligned parallel. See here. When you give the field, they are aligned same parallel to each other. That's why they They show the spontaneous magnetization graph between susceptibility and temperature. Here, see here, at a particular temperature, the ferromagnetic materials, at a particular temperature, the ferromagnetic materials become a paramagnetic material. The temperature is called a Curie temperature. Where the ferromagnetic material changes as a paramagnetic material, the temperature is called the Curie temperature. Antiferromagnetic materials. The materials which with anti-parallel magnetic moments are known as antiferromagnetic materials, and their magnetic moments are shown. See here. Net magnetic moment exists in the direction of applied magnetic field. Relative permeability much greater than 1. Susceptibility is low and positive. Chi is equal to C by T plus Tc. And at a particular temperature, first we increase the temperature, the susceptibility increases. At a particular temperature, the susceptibility suddenly decreases. That temperature is called the Néel temperature. In antiferromagnetic materials, the magnetic moments align anti-parallel. Ferrimagnetic materials. In these ferrimagnetic materials, the alignment of the magnetic moments in opposite direction and moment and magnitudes also different magnitudes. They have different magnitudes and align opposite direction. Those are called the ferrimagnetic materials. Relative permeability mu are much greater than 1. Susceptibility chi is high and positive. Examples ferrites. Chi is equal to C by T plus or minus T.